Welcome back to Mr. DuPage's classroom. This lesson is for my Algebra 2 class. It is solving the quadratic formula day 2 using the discriminant. The quadratic formula, we need to try to remember exactly what that is. The quadratic formula is the opposite of b plus or minus the square root of b squared minus 4ac all over 2a. Okay, so we're going to go ahead and solve this first equation using the quadratic formula. We want to make sure that we are set equal to 0 first, so it would be 3x squared plus 5x minus 2 would be equal to 0. My a then is negative 3, my b would be 5, and my c would be negative 2. So now I can go ahead and solve using the quadratic formula. So x would equal the opposite of b, so negative 5 plus or minus the square root of b squared minus 4 times a, which is negative 3, times c, which is negative 2. All that will be 2 times a, which is negative 3. All right. Now I'm going to go ahead and simplify. So I'll have x equals negative 5 plus or minus 5 squared is 25. Negative 4 times negative 3 times negative 2 would be negative 24. All that would be over negative 6. I'm going to go ahead and bring this up to the right over here. Now I want to continue to simplify. So x would be negative 5 plus or minus the square root of 1 over negative 6. So x equals negative 5 plus or minus 1 over negative 6. Now I need to split up my problem. So negative 5 plus 1 over negative 6 and negative 5 minus 1 over negative 6. Negative 5 plus 1 would be negative 4 over negative 6. That would simplify to 2 over 3. Negative 5 minus 1 would be negative 6 over negative 6, and that would simplify to positive 1. All right. Now, the new piece here, that was all review from our last lesson. The new piece is what is called the discriminant. If I look at the discriminant, this is the formula for the discriminant. If I take that piece and look right up here, you'll notice that is the same thing as what is underneath my square root in the quadratic formula. Remember that because it will come into play in a little bit. But for now, let's just look at the discriminant and the formula. So we're going to consider the graphs of the functions below and the discriminant of each related equation. So what we're going to do is we're going to take these values, so a is 1, b is negative 6, and c is 3. We're going to plug what we have to into the formula for the discriminant and see what the discriminant comes out to be. So b squared would be negative 6 squared minus 4 times 1 times 3. This would be 36 minus 12, which is 24. Looking at my graph, if you remember from our graphing units, my answers to a quadratic are at the x-intercept. So there's 1, there's 2. This graph works with that discriminant. So if I have a positive discriminant, which is right down here, then there are 2 real solutions. Yes, I need to say real. You'll understand why in a second. Okay, let's look at the second equation and the second graph. If I have negative 6 squared, it'd be minus 4 times 1 because my a is 1 times 9 because my c is 9. That would be 36 minus 36, which would be 0. Notice there's one answer here. It is at y equals 0. So this talks about my discriminant being 0. There are 1 real solutions to that problem. The last discriminant, we're going to do negative 6 squared minus 4 times 1 again because my a value is 1 times 12 because my c value is 12. This would give me 36 minus 48, which is negative 12. Notice that it's negative. Notice I do not have any answers on my graph. So if the discriminant is negative, as it says here, then there are no real solutions. What that ends up being is 2 imaginary. There would be 2 imaginary solutions in that situation. All right, so on examples 1, 2, and 3 down here, what I need to do is find my discriminant. That will tell how what kind of answers I'm going to have and what type, real or imaginary. Okay, so I'm going to use my discriminant. So A is 3, B is negative 5, C is negative 1. This would be negative 5 squared minus 4 times A, which is 3, times C, which is negative 1. Negative 5 squared would be 25. Negative 4 times 3 times negative 1 would be positive 12. That would get me positive 37. So I would have 2 solutions, and they would both be real. That is what it is asking us to find, is how many solutions I'm going to have and whether they are real or not. So 5x squared, I've got to make sure it's set equal to 0, so I need to subtract the 2x. Plus 8 is equal to 0. My A would be 5, my B would be negative 2, and my C would be 8. So I'm going to take B, which would be negative 2, and square it, minus 4 times A, which is 5, times C, which is 8. This would get me 4. Then negative 4 times 5 times 8 is negative 160. So this would be negative 156, which would be 0 real solutions, or 2 imaginary. I would accept either one in that situation. All right. On to 3, I got to make sure it's set equal to 0, so I'm going to add the 49. My A would be 1, my B would be 14, and my C would be 49. Again, I'm going to use my discriminant, so it would be 14 squared minus 4 times my A, which is 1, times my C, which is 49. 14 squared is going to get me 196. Negative 4 times 1 times 49 would get me negative 196, which is 0. So that means I would have 1 real solution. All right, on to the back. Again, we need to find the number and type of solutions using the discriminant, and then we need to solve for our x value. I'll explain how we're going to do that in 1 second. Remember your quadratic formula, remember the formula for the discriminant, and remember the fact that the discriminant is what is underneath the square root in the quadratic formula. Okay, so in this case, my A would be 1, my B would be 8, and my C would be 11. Okay, so I'm going to use my discriminant, so it would be 8 squared minus 4 times my A, which is 1, times my C, which is 11. Well, 8 squared is 64. Negative 4 times 1 times 11 would be negative 44. So my discriminant would be 20. That means I'm going to have 2 real solutions. Remember that my discriminant, which is the 20, will be what is underneath my square root in my quadratic formula. So x would equal, for in my quadratic formula, x equals the opposite of b, so it would be negative 8 plus or minus the square root. Remember, everything under the square root is your discriminant, so I'm going to plug that in, over 2 times a, which is 1. I'm going to start simplifying, so negative 8 plus or minus the square root of 4 times the square root of 5 over 2. So x equals negative 8 plus or minus 2 root 5 over 2. That is the farthest I need to take that, because I cannot, I will not be able to simplify that any further, or combine the negative 8 and the 2 root 5. All right. On to number 5. Again, I need to set this equal to 0, so I'm going to add the 5. My A would be 6, my B would be 10, and my C would be 5. I need to use my discriminant, so it would be 10 squared minus 4 times 6 times 5. This would get me 100. Negative 4 times 6 times 5 would be negative 120. So this would be negative 20. I have no real solutions, but I can take negative 20 and put it into my parenthesis. So the opposite of b would be negative 10 is equal, is plus or minus the square root of negative 20 over 2 times 6. So x equals negative 10 plus or minus the square root of negative 1, the square root of negative, or the square root of 4, and the square root of 5 over 12. So x would equal negative 10 plus or minus 2I root 5 over 12. Okay? On to number 6. I would have 3x squared minus 4x minus 7 is equal to 0, because I have to set it equal to 0. My a is 3, my b is negative 4, and my c is negative 7. I'm going to take my b, which is negative 4, and square it. Minus 4 times 3 times negative 7. This would be 16. Negative 4 times 3 times negative 7 would be 84. So my discriminant would be 100, which means I have 2 real solutions. Now I can go ahead and take 100 and put it in for my square root. Take the opposite of b. My b was negative 4, so now it's positive. Square root of 100 over 2 times 3, because my a is 3. So x equals 4 plus or minus 10 over 6. Now I need to go ahead and split this, because I can go ahead and combine like terms. So x would equal 4 plus 10 over 6, and x would equal 4 minus 10 over 6. So x equals 14 over 6, which would simplify to 7 over 3. And 4 minus 10 over 6 would be negative 6 over 6. So x would equal negative 1. All right. Moving on to story problems. We did a little bit with story problems the other day. Let's see what happens here. Reminder, the height h in feet of an object t seconds after it is launched is given by the formula h equals the negative 16t squared plus velocity, or the initial velocity, times t plus the initial height. The initial height being h0 and the initial velocity being v0. A construction worker on the ground tosses an apple to a fellow worker who is 20 feet above the ground. Well, this h right here means height. So we're talking about it being 20 feet off the ground, so I will put 20 in for h. The starting height of the apple is 5 feet. The initial velocity is 30 feet. So remember that this negative 16t squared is just going to stay the way it is. My initial velocity, which is 30, will go in for v0, so it'll be plus 30t. My initial height, which is 5 feet, will go in for h0, so plus 5. Now, what I need to figure out is every time I do a quadratic formula problem, I always set it equal to 0, right? So I need to subtract the 20. That would leave me with 0 equals negative 16t squared plus 30t minus 15. It's asking, will the apple reach the second worker? What that means is I'm going to use my discriminant. When I use my discriminant, if it comes up with 1 real solution or 2 real solutions, then the apple would in fact reach the second worker. If it comes up with no real solutions, then the apple will not reach the second worker. So all I have to use is my discriminant. My discriminant is the b value, which is 30, squared, minus 4 times my a value, which is negative 16, times my c value, which is over here, negative 15. 30 squared will get me 900. Negative 4 times negative 16 times negative 15 would get me negative 960. So that means that my discriminant is negative 60, so no, the apple will not reach the second worker. Now it changes our problem. It says, what if the apple is tossed with an initial upward velocity of 32 feet per second? Well, that means that my formula would change to negative 16t squared plus 32t minus 15, or my equation would change to that, which means my b value has changed. My b value now is 32, so it would be 32 squared minus 4 times negative 16 times negative 15. Well, 32 squared would get me 1,024. Negative 4 times negative 16 times negative 15 would get me negative 960. 1024 minus 960 would be 64. So yes, it would in fact reach the second worker. All right, because remember, if I have a negative discriminant, I will have 0 real solutions. If I have a positive discriminant, I will have 2 real solutions. All right. A machine shoots a ball straight up in the air with an initial velocity of 85 feet per second. The machine releases the ball 5 feet off the ground. Set up the formula first. So again, initial velocity is my b value. The height off the ground is my c value. So I would have h equals negative 16t squared plus the 85t plus the 5. Okay? Now, the ball will be at the height of 25 feet at 2 times before it hits the ground. At what times is the ball at 25 feet? So again, this h that's in my initial equation is the height that we're looking for. So in this case, we're looking for 25 feet. So I'll put 25 feet in for h. The rest of my equation will stay the same. Again, I always need it equal to 0 to start my problem. So it would be 0 equals negative 16t squared plus 85t. Whoop, that's 85t, I apologize. Plus 5. No, I'm sorry. 5 minus 25 would be negative 20. So now I need to go ahead and I'm going to use my discriminant so I don't have to keep writing the entire quadratic formula over and over and over and over. Because if you remember from what I said earlier, the discriminant is the number that goes under my square root. I'm going to go ahead and use my discriminant. So it would be 85 squared, because it's b squared, minus 4 times a, which is negative 16, times b, times c, I'm sorry, which is negative 20. 85 squared is going to get me 7,225. Negative 4 times negative 16 times negative 20 is going to get me negative 1,280. If I subtract those two, my discriminant is going to be 5,945. So I can just now take this 5,945 and plug it in for my number that is underneath my square root. Okay? So I'm going to use the quadratic formula to figure out t, which is my time. It's asking for what 2 times will the ball reach 25 feet. So t would equal, using the quadratic formula, the first step is the opposite of b. Well, my b value is 85, so it'll be negative 85 plus or minus the square root of my discriminant, 5945, over 2 times my a value, which is negative 16. So t would equal negative 85 plus or minus the square root of 5,945. The reason why I'm keeping that square root in there and not going ahead and typing that through my calculator is it'll come up with a decimal, and then I will be estimating. I do not want to estimate this. I can come out with a lot closer value if I just keep the square root of 5,945. 2 times negative 16 got me the negative 32. Now, since I have this all set up correctly, I can go ahead and take negative 85 plus the square root of 5,945. Divide that by negative 32. That would get me t equals 0.25 seconds. So it's going to happen really fast right after it launches. I could also have the opposite, which is negative 85 minus the square root of 5,945 over negative 32. If I type the numerator straight through my calculator, hit enter, then divide by negative 32, what I'm going to get is 5.07 seconds. So those are the 2 times that the ball would reach 25 feet. If you think about what a quadratic looks like, it goes up to a certain height and then starts coming back down, so it would hit 25 feet 2 different times. The most important thing to remember here is when I am working through a quadratic formula problem, as you can see here again, I can just use my discriminant so I don't have to write the entire formula over and over and over, and I can just plug that back into underneath the square root. Once I do that, then I can just simplify and solve from that point. That is our lesson for today. Thank you very much for watching my video. Make sure if you have any questions, you bring them in and ask, and have a great day.